Hello, this is part 2 of week 11 tutorial. In this part, we will do some examples of polar coordinates and then we will do some double integral applications. Okay, so the first question of polar coordinate is evaluating the double integral sine of x square plus y square dA over the region R, where R is the region and first quadrant and between the circles of radius 1 and radius 3. Okay, so if we draw this region over which we are evaluating this integral, the region will be somewhat like this. This is the circle of radius 1 and this is the circle of radius 3. And since we are looking in first quadrant, so this is the region over which we are evaluating this integral. Okay, so the limits of radius will be from 1 to 3, and the limit of theta is angle is in the first quadrant, so the theta moves from 0 degree till pi over 2. So the limits of theta are from 0 to pi over 2. Had the region been in quadrant 1, quadrant 2, तो और थीटा would have been from 0 to pi, और अगर हमारे जो रीजन होता है वो सारे क्वाड्रेंट में होता है तो और थीटा would have been from 0 to 2 pi. ओके, सो पोलर कोऑर्डिनेट्स में हम कुछ सब्स्टिट्यूशन करते हैं. इंस्टेड ऑफ एक्स स्क्वायर प्लस वाई स्क्वायर वी राइट आर स्क्वायर एंड वी प्लग एक्स इज इक्वल टू आर कॉस थीटा, वाई इज इक्वल टू आर साइन थीटा, एंड जो इंटीग्रेशन में डी ए को जो हम डी वाई डी एक्स या डी एक्स डी वाई से रिप्लेस करते हैं, इस केस में इन केस ऑफ पोलर कोऑर्डिनेट्स वी राइट डी ए इज आर डी आर डी थीटा, not just dr d theta. Okay, so if I plug in sine of x square plus y square is r square and dA is r dr d theta, and the limit of integration are, the radius is going from 1 to 3 and theta is going from 0 to pi over 2. Okay, now साइन ऑफ आर स्क्वेयर एंड आर स्क्वेयर का जो डिरेवेटिव है 2r इज प्रेजेंट आउटसाइड, और इसको एग्जैक्ट 2r बनाने के लिए आई डिवाइड एंड मल्टीप्लाई 2 विद इट, तो आई गेट 2r साइन ऑफ आर स्क्वेयर dr d theta. Okay, now I can separate out the integrals. The integral are from 0 to pi over 2 and theta is just d theta, and radius is from 1 to 3 of 2r sine of r square dr. The first integral is just integrating 1 with respect to theta, which is theta, and the limits are from 0 to pi over 2 minus the integral of 2r sine of r square. Sine of r square का derivative बाहर मौजूद है, तो I can just write this as this times negative of cos of r square, and evaluating this at limit 3 and 1. Okay, if I plug in theta is equal to pi by 2, I get pi over 2, and if I plug in theta is equal to 0, I get 0, so I'm ignoring 0. Times, if I plug in cos of if I plug in r is equal to 3, I get minus cos of 9. Negative times negative will make it a positive, and if I plug in r is equal to 1, so I'm getting cos of 1. Okay, so the final answer I'm getting is pi over 4 times cos of 1 minus cos of 9. The next question is evaluating the double integral x square minus y square e to the power x square plus y square dA, or the region R, where R is the region enclosed in x square plus y square equal to 1. Okay, x square plus y square equal to 1 is the equation of a circle with radius r is equal to 0. So I can just draw that out. This is a circle of radius 1, and since quadrant हमें नहीं given कि किस quadrant में, तो we'll take के सारे quadrant में, मतलब इस क्वाड्रेंट में भी, इसमें भी, इसमें भी एंड इसमें भी, इन चारों क्वाड्रेंट में चारों क्वाड्रेंट को इज अ रीजन कंसिडर करेंगे। तो थीटा विल गो फ्रॉम 0 to 2 pi and radius is going from 0 to 1. Okay, radius की लिमिट are from 0 to 1 and theta की limits are from 0 to 2 pi. Okay, so if I plug in x is equal to r cos theta, I get r square cos square theta, and y square is r square sine square theta times uh, e to the power x square plus y square is r square, and instead of dA I am writing r dr d theta. Limits of r are from 0 to 1 and theta is going from 0 to 2 pi. Okay, I can just take r square common, and we will be left with cos square theta minus sine square theta, which is cos of 2 theta, and e to the power r square, e to the power r square r dr d theta, which is if we separate out r square की terms and theta की terms, तो theta की term is just cos 2 theta d theta, and r की terms are r cube dr, right? uh, okay, no, it's not just r cube, it's r cube e to the power r square dr. Okay, if you notice कि ये वाला जो integral है, this is 0. Why is this 0? Because we are integrating it over its period, 2 times its period. Because cos theta का period is 2 pi, and the period of cos 2 theta is just pi. And what does the period mean? कि cos 2 theta की अगर हम बात करें तो its period is pi, तो in 1 pi it will complete its 1 revolution, और दूसरे पाई में it will complete its second revolution. तो x एक्सिस के ऊपर का जो एरिया, that is equal to x एक्सिस के नीचे वाला एरिया. So the net area is 0, so the integral will be 0. 0 times the integral from 0 to 1 of r cube e to the power r square dr, which is equal to 0. The next question is evaluating the double integral arc tan of y over x, or the region R, if the region R is x square plus y square is greater than 1 and less than 4, and y is greater than 0 and less than x square. Oh, it's just x. Okay, if we draw the region just by we are computing this integral, it would be like this. I can just write x square plus y square is equal to r square. So, and taking square root on all sides, so I get radius is going from 1 to 2. So I'll draw two circles, one of radius 1 and the other one of radius 2. Okay, so the radius is going from 1 to 2. So this region. Okay. And uh, y is going from 0 to x. So that means कि y is equal to 0 की line ये है and y is equal to x की line is this one, making 45 degree with the x-axis. So our theta is going from 0 to 45 degree, which is pi by 4, and radius is going from 1 to 2. This is the area. This is the region just where we are evaluating this integral. So theta is going from 0 to pi over 4. Okay. Uh, Rewriting this integral, arc tan is tan inverse. So instead of y, I put r sine theta, and x is equal to r cos theta. dA is r d theta, and the limits of r are from 1 to 2, and theta is going from 0 to pi over 4. R cancels out, and sine over cos is tan theta. Okay. Tan inverse of tan of x is equal to x. So using this identity, क्योंकि this is just f inverse of f of x is just x. तो वही identity हम इधर use कर रहे हैं. So the integral will become from theta की limit from 0 to pi over 4, radius की limits from 1 to 2 of just theta, r dr d theta. Splitting this integral, theta की terms from 0 to pi over 4 of theta d theta, and radius की limit from 1 to 2 of r dr. Uh, Integrating theta with respect to theta, I get theta square over 2, and the limits are from 0 to pi over 4 times. Integrating r with respect to r is r square over 2, limits are from 2 to 1. Okay. If I plug in theta is equal to pi over 4, I am getting pi square over 16 divided by 2, minus if I plug in theta is equal to 0, then I'm getting 0. I'm skipping that. And r is equal to 2, I get 4 over 2, minus if r is equal to 1, I get 1 over 2. So this is pi square over 16 over 2 is pi square over 32, and 4 over 2 minus 1 over 2 is 3 over 2. So this is 3 pi square over 64. Okay, now we'll do two examples on applications of double integral. So one application is uh, if you want to find the area of a surface uh, on a region, on a region R, so just evaluate the integral 1 plus partial x square plus partial y square. Evaluate this over that region R, where partial x is surface का partial with respect to x ले लें and surface का partial with respect to y ले लें. Okay, so the question we are having is find the area of the surface z is equal to 4 minus x square minus y square that lies above the xy plane. Okay, z is equal to 4 minus x square minus y square is a paraboloid which opens downward because x square and y square की जो signs है वो negative है, so it's opening downwards. And uh, if I draw this paraboloid, it will be force start होगा and it will open downwards. And since we are considering above xy plane, so just write it z is equal to 0, we will stop. the हम z is equal to 0 से लेकर z इज इक्वल टू 4 तक ये वाला जो रीजन है, इसके ऊपर हम इसको इंटीग्रेट कर रहे हैं। ओके, सो now अदर थिंग के अगर हम इसकी लिमिट्स निकालना चाहें, बिकॉज इट्स, अगर हम इसको 2D में देखें तो इसको एक्स वाई में प्लेन में प्रोजेक्ट करें तो इट विल बी अ सर्कल जिसका रेडियस विल बी 2, राइट? बिकॉज एक्स स्क्वायर प्लस वाई स्क्वायर इज इक्वल टू 4 बन जाएगा इफ आई टेक z इज इक्वल टू 0। तो एक्स स्क्वायर प्लस वाई स्क्वायर इज इक्वल टू 4, और जो कि इक्वेशन ऑफ अ सर्कल होती है। एंड उस सर्कल के ऊपर हम इसको इंटीग्रेट करेंगे तो रेडियस विल गो फ्रॉम 0 to 2 एंड थीटा विल गो फ्रॉम 0 to 2 पर। Okay, so evaluating the integral of partial x will be, partial x of this is minus 2x and partial y is minus 2y. And evaluating the integral 1 plus partial x square is negative 2x square is 4x square and negative 2y square is 4y square. And instead of dA, I am writing r dr d theta, and the limits of r are from 0 to 2 and theta is going from 0 to 2 pi. Okay, now you can see if I take 4 common, so I can write this integral is 1 plus 4 times x square plus y square, and that x square plus y square I'm writing that is x square plus y square is equal to r square and r dr d theta. Okay, uh, now you can see that 1 plus 4r square की पावर 1/2 है, and the derivative of which is this is 8r, which is present outside. To make it 8r, I multiply 8 with it and divide it outside. Okay, uh, now what I can do is के r की terms अलग कर लें and split the integral. Theta will be from 0 to 2 pi, and it's just d theta, and the radius is going from, I can write 1 plus 4r square is 1 plus 4r square whole power 1/2 times 8r dr. 1/8 integral of 1 with respect to theta is theta. Evaluating this at limit 2 pi and 0 times 1 plus 4r square, उसका एक डेरिवेटिव भी हमारे पास मौजूद है, तो I'll just increment its power by 1. 1/2 plus 1 is 3/2 and divide the power as well. And I need to evaluate this at limits 0 and 2. Okay, 1/8, if I plug in theta is equal to 2 pi, and I get 2 pi, and if I plug in theta is equal to 0, I'm getting 0, so I'm ignoring the 0 term. And if I plug in r is equal to 2, I'm getting 1 plus 4. 2 times 2 is 4. 4 times 4 divided by 3/2 minus, if I plug in r is equal to 0, I'm getting 1 plus 0 divided by 3/2, which evaluates to this 2 and this 8 will cancel out, making it pi/4 times 4 times 4 is 16. 16 plus 1 is 17/3/2 minus 1/3/2. I can just take 3/2 outside, which will make it 2 pi over 12 into 17 minus, oh, I just ignored this thing. Its power will be 3/2. It will remain as it is. So I'm left with 17 power 3/2 minus 1 power 3/2. It's again 1. So 2 and 12 will cancel out, making it pi/6 times 17 to the power 3/2. I can write that as 17 under root 17 minus 1. which is the answer. Okay, one last question, which is find the area of the loop of area. Find the area of one loop of rows r is equal to cos 3 theta. So if I draw it on decimals पोलर कोऑर्डिनेट्स में तो cos 3 थीटा का जो ग्राफ होता है इस तरह होता है. Okay, now we need to compute area of only one loop. So we will compute the area of this loop, right? And this loop में because radius is going from 0 till this point, and this point is cos 3 theta. The radius की limits are from 0 to cos 3 theta, and the angle, for angle what we will do is के make this r cos theta equal to 0 because r जो है वो 0 पे स्टॉप भी हो रहा है और एंड भी इसी पे हो रहा है. स्टार्ट भी इधर से हो रहा है और 0 पे एंड भी हो रहा है. तो r इज इक्वल टू 0. सो आई गेट cos 3 थीटा इज इक्वल टू 0. एंड cos कब 0 होता है व्हेन थीटा इज इक्वल टू पाई ओवर 2 और उसके जो मल्टीपल्स होते हैं बाकी कोऑर्डिनेट में. तो आई कैन टेक दिस इज just 3 theta is, since we are talking about this quadrant or this quadrant, first or fourth quadrant mein, so I'll just take pi over 2 or negative pi over 2, making the theta equal to pi over 6 and negative pi over 6. Okay, so you can clearly see that this is pi over 6 or this is negative pi over 6. So where the limits of theta are from negative pi over 6 till pi over 6. Okay, rewriting this integral is the integral will be uh, r d theta because we are finding the area. So I'll just integrate this on 1, and the limits of r are from 0 to cos 3 theta, and the limits of theta are from negative pi over 6 till pi over 6. Okay, you can't split out because limits में आपके पास थीटा की टर्म आ रही है, तो आप r और थीटा को सेपरेट नहीं कर सकते. तो you will have to evaluate the r term first. So integrating r with respect to r, you get r square over 2, plugging in cos 3 theta and 0 d theta, negative pi over 6 and pi over 6. And if we plug in r is equal to cos 3 theta, so you get cos square of 3 theta over 2 minus 0. I'm skipping that again. And cos square 3 theta की identity होती है, which is 1 plus cos of 6 theta divided by 4. I'll just write this is negative pi over 6 and pi over 6, 1 plus cos 6 theta over 4 d theta, uh, negative pi over 6 and 1 over 4 को अलग कर लें, plus the integral of minus pi over 6 till pi over 6 of cos 6 theta over 4 d theta. Okay, 1 over 4 को integrate करें with respect to d theta. Here we will be having d theta, so that will become theta over 4. The limits will be from negative pi over 6 to pi over 6, plus the integral of cos 6 theta, and 6 theta का derivative with respect to theta will be 6. So to make 6 outside of it, I'm multiplying and dividing it with 6. Now 6 theta, cos 6 theta, and 6 theta का जो derivative है 6, which is present outside. So 1 और 6 as it is लिख लें, and 4 को भी बाहर निकालें. तो 6 times 4 is 24. एंड द इंटीग्रल ऑफ cos 6 थीटा टाइम्स 6। हमने सिर्फ इस चीज़ का इंटीग्रल लेना है एंड दैट इज साइन ऑफ 6 theta and the limits are from negative pi over 6 till pi over 6, and if I plug in theta is equal to pi over 6, I get uh, pi over 6 divided by 4. Negative times negative, making it a positive, plus pi over 6 divided by 4. uh, ये इधर से आ रहा है हमारे पास. Now evaluating the next term, I'm getting uh, if I plug in sine 6 theta, so sine of 6 times pi over 6 is pi, uh, minus minus again, making it a positive, plus 1 over 24, and sine of if I plug in theta is equal to pi over 6, so again I'm getting minus pi over 6. So again it will be just negative 1 over 24. So sine of pi and sine of negative pi both are 0, so I'm just left with the first two terms, which are pi over 6 divided by 4 and pi over 6 divided by 4. I can write that as this, and 2 and 4 will cancel out. So pi over 6 divided by 2, which is pi over 12. That was it for this part. Thank you.